So May June 2016, Unit 1. In question 6, in this synthesis of ammonia, 56 gram of nitrogen reacted with excess of hydrogen, means more than enough hydrogen is there. The mass of ammonia produced is 6 gram. What is the percentage yield? So basically, the percentage yield is a practical value of a product divided by theoretical value into 100. So practically, we are getting 6 gram of ammonia from 56 gram of nitrogen. But theoretically, how much we should get? So the ratio nitrogen and ammonia, because the mass is given, so what is the ratio of the mass? So nitrogen 14 multiplied by 2, that is 28. And ammonia, nitrogen is 14 plus hydrogen 3, 17 multiplied by 2, 34. So the ratio is 28 will give 34. If we have 56, this will be x cross multiply. So when you cross multiply, because if this is double, this will be double, so this will be 68 grams. So according to theory, you should get 68 gram, but practically you're only getting 6 grams. So percentage yield, the formula for percentage yield is a practical value divided by theoretical value into 100. So practically we are getting 6 gram, but theory suggests we should get 68, and we'll multiply by 100, so we'll get the yield, which is 8.82. Any other doubt in MCQs? From question 1 to question 16. In question 11, what is the IUPAC name of the following hydrocarbon? So first thing, what you have to do, you have to select the longest chain of the carbon. So if I select the longest chain of the carbon, 1, 2, 3, 4, 5, 6, 7. If I start from here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, or 1, 2, 3, 4, 5. So maximum 7 carbon atoms in one chain. So we have a 7 carbon atoms in one chain. Now we will number these carbon. Numbering should start from nearest branch or functional group. So 1, 2, 3, 4. So if I number from the bottom carbon, the branch is at 4th. If I number from the top carbon, the branch is also at 4th. So I can follow any numbering. But fourth position, we have two branches. One is a methyl branch and another one is ethyl branch. And when we name the branches, we should follow the alphabetical order. So it is fourth position, we have ethyl. Fourth position, we have methyl. And because there are 7 carbons, so it is hept. And they have a single bond N, so it is 4, 4, 4 ethyl, 4 methyl heptane. That's why D is the right answer. Is it clear? Any other doubt in MCQs? Okay, moving to the questions. Question number 17, the structure question, question 17. Is there any doubt in any part of this question 17? So in question 17, part D1, in a mass spectrometer, a sample of the vapor of an element is ionized. state how this ionization is carried out. So how we carry out this ionization? Basically, we target the element by a fast moving electron. So this electron will knock out, or the electron from the atom, the element, which result in a formation of ion. But we just have to mention how it is done. So target the atom, target the element by fast moving electron which knock out electron from the atom. Then complete the equation to show the simplest ionization of vaporized element M. So basically what we do, we target this by electron. So electron is removed. So when something loses electron, what it will get? It will get a positive charge if one electron is removed. And as a result, we will get two electrons. Why two electrons? The one which we use to knock out and the one which is removed from the atom. So two electrons are produced. That's why we will write 2e. Then how are ions accelerated in a mass spectrometer? To accelerate the ions, what we use electric field is used to accelerate the ions. So we use electric field to accelerate the opposite charged ions. Then in this question, ions with some charge with same charge and ions with the same charge and traveling with the same speed are then passed through a magnetic field. The path of an ion is shown. We have to add a line to show the path of a lighter. So if it is a lighter, what we will observe when we apply? So lighter, because it will experience greater magnetic field, so it will deflect or it will deviate more. So when we show the path of a lighter particle, we should show a greater deviation. And same thing if they say sketch a path for heavy. So heavy compared to that, it will have less deviation. So this one is a heavy particle where red one is representing the lighter particle. A sample of silicon is analyzed in a mass spectrometer. Calculate the relative. C was not the doubt, D was there. High resolution mass spectrometer measure the masses to 4 decimal places. The relative molecular mass of a compound is found to be 84.0581. The relative atomic mass of oxygen is 15.9949 and relative atomic mass of hydrogen is 1.0079. Use the data, deduce whether the compound is C6H12 or C5H8NO and show your working. So basically what we have to do, we have to find the mass for each and we have to compare that which one it matches with the final result. So If we are saying the compound is C6NH12, so what is the mass of the carbon? Carbon is 12. And what about the mass of hydrogen? It is 1.0097. And there are 12 hydrogens, so you will multiply that value by 12. So this will be 6 multiplied by 12 plus hydrogen mass is 1.0079 multiplied by, here 6 atoms are there, and multiply by mass of one carbon, which is 12. 1.0079 multiplied by number of hydrogen, 12. And same way C5H8 and O, so that will be 5 multiplied by 12 plus hydrogen is 1 multiplied by 8. Not exactly 1, because it is given the accurate value for hydrogen is 1.0079 multiplied by 8, and for oxygen it is 1 only, and each oxygen is having a mass of 15.9949. So which one it matches with when you work out? So this will be 6 into 12 plus 12 into 1.0079. That will be equal to 84.0948. And the other one is 84.0581. And if you check the original, that matches with C5H8 and O. So means that compound is C5H8 and O. And now what is our assumption here? The second part, like when we did this calculation, what we assume here, because for carbon you can see we consider carbon 12, exactly 12. So this is our assumption that we don't have any isotope of carbon, only the carbon is present, it does not have any isotope. That's why the mass of carbon is exactly a whole number. But for others, it was like the average mass of 2 or more isotopes. Helium mass spectrometer is an instrument used to detect leaks in a container. Like if a container is having leaks, so we can use this helium mass spectrometer. A sealed container filled with helium is placed in a vacuum chamber. Any helium leaking out of the container is detected by a mass spectrometer. Suggest one reason that makes a helium suitable for this purpose other than its lack of reactivity. Like it is less reactive, that is one reason, but other than this, what could be the reason why we are using this helium? So reason for that, to determine the leakage, because how we are using helium mass spectrometer used to detect leaks in the container. So if I want to find the leak in any container, if a small leakage is there, if there is a small opening, so if I'm using, like example, nitrogen is there, oxygen is there, or any other gases, these molecules are larger in size as compared to that of helium. So helium atoms are smaller in size. So as they're smaller in size, they can pass through these leakage or gaps. So we can identify any leakage in the container. But with other gases, it will be difficult. The other gases, the containers are there. So for other gases, the molecules are larger in size. So the maybe the molecules are not able to go out from a small hole. So the helium, why it is used, like we prefer to use helium rather than other gases, because it is lighter, so it can diffuse faster, and it is having a small size, so small gaps it can flow out. Is it clear, this question? Question 18. Is there any doubt in any part of question 18? Question 18. Is there any doubt? D4. Aluminium chloride has more covalent character than magnesium chloride. Explain what this statement means by considering a physical properties of the two chlorides suggests one piece of evidence show that the aluminum chloride has more covalent character than magnesium chloride. So what is the basic meaning of a covalent character? Because in ionic compound, what it appear that basically what happened in ionic compound, the electron transfer from one atom to another. So this result in a formation of ionic bond. So as the ionic bond is formed, but what happened due to a polarization or distortion in the negative ion, the ions come relatively closer to each other. So the experimental lattice energy and the theoretical lattice energies will have different. So example, if we take aluminum with, as we move across the period, like we have sodium, we have magnesium, and we have aluminum. So as we move across the period, the atomic size decreases because they have same number of the shells but greater nuclear charge, which leads to decrease in size. So if I compare aluminum chloride, so this is aluminum ion and the chloride ion is there, and we have magnesium and chloride ion is there. Now, when there is an electron transfer, chloride will get a negative charge, aluminum will get a positive charge, same thing, magnesium will get a positive and chloride will get a negative. Aluminum is small, aluminum ion, the positive ion is smaller in size. So what it will do, it will attract the electron which are present in chlorine, and the attraction of this electron towards this electron cause a distortion in chlorine. So due to this distortion, what it appear, it appears that instead of electron being transferred, it looks like that electrons are shared between them. Magnesium is smaller charge density, so it will cause a distortion, but less distortion. So aluminum chloride has a more covalent character than magnesium. And so what is the meaning? That aluminum, which is smaller in size, which will cause more distortion to the chloride ion. And due to this distortion, what will happen? It will create a difference between the theoretical lattice energy. There will be a difference between theoretical lattice energy and the practical lattice energy. Means it will be higher value, like if theory suggests lattice energies are bond forming exothermic, so if theory suggests that maybe 100 kilojoule per mole is there, but practical value will be a bit higher because the ions are closer, so required greater amount of energy to separate them. So aluminum positive ion, which is smaller in size, cause more distortion to the chloride ion. And what it appeared that electron density shifted more towards aluminum, and sharing of electron, rather it appeared that the electrons are shared rather than transfer, which leads to the difference between the theoretical and the practical value of lattice energies. Is it clear? Question 19, is there any doubt? Question 19. 19C and D, again it is related to enthalpy change. So we will discuss enthalpy change questions in unit 2 according to new specification. C and D are related to enthalpy change. Any doubt in question 20? Any doubt? So this was unit 1. The enthalpy question, because that according to new specification, the enthalpy change, energy change, Born-Haber cycle, Hess law is in unit 2. That's why we will do questions from unit 2. So group 2 and 7. Group 2 we already discussed group 2, and now today we'll start group 7. Group 7 are known as the halogen. The term halogen is refers to the salt former. The elements which are included in this group, we have fluorine, chlorine, bromine, and iodine. The appearance of these elements, fluorine, which is a pale yellow or light yellow gas, and it is highly reactive because it is small in size. So non-metal tend to gain electron. So due to smaller size, it can gain electron easily as compared to other elements in the same group. Chlorine also exists as a diatomic molecule. It's a yellowish green or a greenish gas, poisonous in high concentration. Bromine is there, which is a red-brown liquid or volatile liquid. It also exists as a bromine diatomic molecule, and this gives off a dense brown or orange poisonous fumes. If iodine is there, it's also existing as a diatomic molecule, which is shiny or a gray solid, and it sublimates. Sublimation here refers to directly convert from solid to gas. Now, trend in the melting and the boiling point. So, what we observe, it increases as we go down the group. Like why it happen as we go down the group? Why the melting point is increasing? The same idea is that when you compare, first thing you have to compare the type intermolecular forces. Intermolecular force can be dipole force, it can be dipole induced dipole force, or London dispersion force, or which is also weak van der Waals force, or it can be hydrogen bond. So if you have a fluorine, then you have chlorine. These are the two molecules of chlorine. The first one, two molecules of fluorine. And if I draw iodine and bromine, so which type of intermolecular force is there? Because there are no dipoles here. If they don't have dipoles, so they cannot have dipole force. But what happens when the molecules collide or come closer to each other? They cause distortion, shifting of the electron density. So when the molecules create dipole, we call that as dipole induced dipole force. So it will create a partial positive and negative when the molecules are colliding, when they are closer. But because electrons here, when you compare the number of electron, fluorine, each fluorine is having 9 electrons. So 9 electrons here, 9 electrons. So these electrons, what they are doing, they are attracting the nucleus or attracted towards the nucleus. Same thing, 9 electrons with each, and they are attracted towards the nucleus, but only 9 electrons, so weak attraction. But when we compare chlorine, which is having 17 electrons, and these 17 electrons are attracted towards the nucleus. So what it caused? It caused greater, like it increases the strength of the force, leads to higher melting or boiling point. So as we go down the group, the melting and the boiling point will increase. So as the molecule become larger, they have more electrons. So have the larger van der Waals forces between the molecule, and as the intermolecular forces get larger or more energy is needed to separate the molecule from each other. That is why the boiling point, the general trend of a boiling point, it increases as we go down the group. Is it clear? The idea, the reason why the melting point or the boiling point increases. Is it clear this part? The reason, the variation in the melting and the boiling point for halogens. Now, the reaction, this table is actually showing the reaction. Always the more reactive halogen displaces the less reactive halogen from its compound. Oxidizing agent means by itself it is reduced, and reduction means it will gain electron. So halogen that is stronger oxidizing agent will displace the halogen with a lower oxidizing power. So an oxidation power, as we go down the group, it is decreasing. So example, if we have potassium chloride and we bubble bromine, we add bromine, so yellow solution and no reaction is there. And if we add potassium chloride and iodine to this, again no reaction, because the reason is that always the more reactive halogen displaces the less reactive halogen from its compound. So we have fluorine, chlorine, bromine and iodine, and as they are going down the group the reactivity is decreasing. So if I try to react potassium fluoride with chlorine, because chlorine is less reactive, so there will be no reaction. But same way, if I have potassium chloride and I add fluorine, so fluorine is more reactive, it will displace, it will form potassium fluoride plus chlorine molecule. So the more reactive halogen displaces the less reactive halogen from its compound. So you can see, if you have potassium bromide, aqueous potassium bromide, and you bubble chlorine, so what happened? Chlorine is more reactive, so it will displace bromine and the solution will turn yellow. If you add potassium bromide, solution is there, and you try to add iodine, there will be no reaction because iodine is not reactive. Same thing, potassium iodide, you bubble chlorine, chlorine is more reactive, the solution will turn brown. Look, why the solution turned brown? It's because of iodine molecule. You have to keep the colors of the iodine. The color of the iodine, if we have iodine in a greater proportion in aqueous, then it will be brown in color. But if iodine is small proportion in aqueous, it will be yellow in color. But if iodine is present in an organic solvent, the organic compound, then it will be pink or purple is the correct one. So same thing happen here. When we bubble or when we add chlorine, chlorine will displace iodine, so the solution will turn potassium chloride. But because iodine molecules are formed, that's why the solution turns brown. Same thing, bromine, when we add bromine to potassium iodide, bromine will displace iodine and the solution will turn brown here again because of iodine molecule. So the color of the solution in a test tube, which free halogen is present, chlorine, very pale green solution, often colorless, it is acceptable, bromine is there, yellow, and iodine is there, brown. So you have to learn these observations. And this is the equation which represent that chlorine is more reactive, so it will displace bromine from its compound, turn into chloride, and iodine. Chlorine is there, displace iodine from its compound. Bromine is there, it will displace iodine from its compound. Is it clear? The reactions of halogen. The first one, this one is in aqueous, like dissolved. This one, observation if organic solvent is added. Organic solvent means like hexane is there, inside hexane you're carrying out this reaction. So color of the bromine is yellow, but for iodine the solution will be purple and chlorine will be colorless. Is it clear to everyone? These reactions of halogens in aqueous and in organic solvents. Any doubt?